Hi, welcome to our physics project.
Car accidents have grown to become a common occurrence. Oftentimes, even when one wears a seatbelt and an accident occurs, the person can be severely injured unless protected by an airbag. In this project, we attempted to construct an airbag to minimize the force exerted during a collision, as well as allowing a cart with a block on top to stop without the block falling over.
The physical requirements included the items provided by the team spending less than $10, ensuring that the airbag only extends less than 15 centimeters past the front of the cart, but also that the airbag attaches and can be removed without damage to the cart. The functional requirements are that the airbag minimizes force upon impact, the wooden block does not fall over at any point, and the cart stops at impact. Also, the cart starts at rest at top of the ramp with a height of 30 centimeters and rolls down the ramp, then strikes the force sensor plate at the bottom of the ramp while the airbag remains attached the entire time.
For our initial prototype, a plastic Ziploc bag was filled with tissues and then wrapped around with bubble wrap, and finally taped to the cart. The block was taped at the front onto the cart, leaving distance between the block itself and the airbag/front of the cart.
So we hypothesized that the first prototype would allow the cart to maintain the block's position after the collision while minimizing the force that is exerted during the collision, because it would increase the time during which the momentum changes are increased, resulting in the least amount of damage. The independent variables were the materials and styles, like this bubble wrap plastic Ziploc bag with tissues of the different prototypes. The dependent variable was the force exerted during the collision and ultimately whether the wooden block falls over during the collision.
For this prototype, we used the constant materials such as the ramp, computer, cart, force plate, and wooden block. For the specific design, we used the plastic Ziploc bag, tissues, bubble wrap, and tape. For the testing, we first hooked the force plate up to the computer, which had Logger Pro on it, to record the graph. Then we filled the bag with tissues, taped bubble wrap around it, and taped it all to the cart. Then we put the cart onto the ramp and let it slide down and hit the force plate, which recorded a graph on the computer of force versus time.
For the qualitative data, we observed that the cart collided with the force plate and then recoiled back. This recoil caused the block to tip forward but didn't return it to its original position, which means it caused damage in a real accident. This refuted our hypothesis and purpose, although it did not fall off. For the quantitative data, the force plate allowed for a table from the graph force time in Logger Pro, which showed these measurements. This is the graph that was pulled from Logger Pro, and this was the equation. F equals negative 2,241 times t squared plus 1.268 e times t minus 1.792 times e. The final value for the force was 10 newtons, which was the maximum force exerted at the time, 2.82 seconds.
For the second prototype, a grocery bag filled with air was tied up and was taped to the front of the cart. In addition, the block was taped at the front onto the cart, leaving distance between the block itself and the airbag front of the cart.
So we hypothesized that the final prototype would allow the cart to maintain the block's position after the collision while also minimizing the force that is exerted during the collision, because it would increase the time during which the momentum changes are increased, resulting in the least amount of damage. The independent variables were the materials such as the plastic bag, the cart, and the block, and the styles of different prototypes, in this case a plastic bag filled with air. The dependent variables was the force exerted during the collision and ultimately whether the wooden block falls over during the collision.
For the final prototype, we used the constant materials such as the ramp, computer, cart, force plate, and wooden block. For the specific design, we used a grocery bag, air, and tape. For the testing, we first hooked the force plate up to the computer, which had Logger Pro on it, to record the graph. Then we blew up the grocery bag, tied it up, and then using masking tape, attached it to the front of the cart. We made sure that the bag could not slow down the cart, and we then put the cart on the ramp and let it slide down and hit the force plate, which recorded a graph on the computer of force versus time.
For the qualitative data, we observed that the cart collided with the force plate and then recoiled back. This recoil caused the block to bounce forward a bit while still maintaining its original position, causing no damage, which supported our hypothesis and purpose as it did not fall off. For the quantitative data, the force plate allowed for a table from the graph of force versus time in Logger Pro, which showed these measurements. This is the graph that was pulled from Logger Pro, and this is the equation F equals negative 3.748 E times T squared plus 1.579 E times T minus 1.633 times E. The final value for the force was 56 newtons, which was the maximum force exerted at the time, 2.1 seconds.
Since the final prototype had a force of 56 newtons and allowed for the block to mostly stay in place without falling or flipping over, the airbag achieved the purpose by minimizing the force exerted while keeping the block on the car. All requirements were met as the plastic bag was provided by our team and was less than $10, did not extend more than 15 centimeters past the cart's front, and could be easily removed without any damage to the cart. Also, the final prototype minimized the force upon impact while keeping the block from falling over. The cart started at rest at the top of the 30-centimeter high ramp and struck the force plate at the bottom, while the airbag was attached the whole time.
So while building, a couple issues we encountered were that the materials were oftentimes difficult to attach to the cart as the masking tape was not as strong. Also, some of the materials were hard to find since we originally wanted to use a styrofoam block, but were unable to find one. And then when testing, the prototypes would sometimes go under the cart and make the cart fall off the track. Also, we had difficulty in setting the force plate up to the computer, which sometimes caused errors in collecting data.
The changes made to the second prototype to minimize the force exerted during a collision, as well as allowing the cart with the block on top to stop without the block falling over, were to have an airbag with an air-filled core instead of an airbag with a packed core, and to also change the material used from a plastic baggie wrapped in bubble wrap filled with tissues to a regular grocery bag from Kroger. These changes were made in the second prototype because the air-filled core allowed the bag to blow up, resulting in an equal and opposite reaction that held the block in place when the airbag collided with the force plate and the force was exerted back on the cart, keeping the block in place.
One improvement for a future prototype could be that the Kroger plastic bag could be poked with holes and then completely blown up with air, so that when it collides with the force plate, the holes would allow the larger amount of air to quickly leave and minimize the force, allowing the block to stay still.
Thanks for watching!